Hey there, Unmaskers, welcome to my channel. In today's episode, we'll discuss how to perform an automated upgrade of Windows Server 2012 R2 to Windows Server 2016 using AWS Systems Manager. A while back, Microsoft announced the Windows Server 2012 and 2012 R2 reaching end of support on October 10, 2023. Naturally, after this date, these products will no longer receive any security updates, bug fixes, or technical support from Microsoft. So if you are running Windows Server 2012 or 2012 R2, one of the options would be to consider upgrading it to a latest supported operating system. That would be Windows Server 2016, 2019, or Windows Server 2022 at the moment. AWS Systems Manager actually provides you an automation document called as AWS EC2 Clone Instance and Upgrade Windows to perform this upgrade for you. This is an automated upgrade process. However, the underlying process of upgrade is actually an operating system level activity. In this page, you can see the natural upgrade paths that are supported by this document. I will link this document in the description below, but I highly recommend that you read this document before you actually go through this procedure so that you understand the prerequisites and the limitations and the parameters that you need to work through while using this document. The AWS Systems Manager document only orchestrates or automates the Windows Server upgrade process for you, which is still an operating system level activity. So it's important to go to the Microsoft documentation to have an overview of what Windows Server Upgrades actually does to sort of understand what are your supported operating system parts. For example, if you take a look at this documentation, Microsoft recommends that the supported upgrade paths for Windows Server 2012 R2 is Windows Server 2016 and 2019. However, if you were to upgrade Windows Server 2008 R2, you cannot directly upgrade to Windows Server 2016. You would first need to consider upgrading your operating system to Windows Server 2012 R2 and then perform another upgrade to get from Windows Server 2012 R2 to 2016. So this document also covers a lot of prerequisites, the limitations, and some of the gotchas that you really need to consider when performing a Windows Server upgrade. So please do take some time to read through this documentation before you actually go ahead with this process. The upgrade operation is actually a multi-step process that can take about 2 hours to complete. The automation first starts by taking the original instance, which is a Windows 2012 R2 operating system, and then creates an AMI from that instance. This AMI is called image from original instance, as you can see in the diagram on the screen. Using this AMI, a temporary instance is launched in the subnet ID that you specify when you use this automation document. The security groups that were associated with the original instance is also applied to the same temporary instance. The automation document then performs the in-place upgrade on this temporary instance to the target Windows version that you selected when running this automation document. The target version in this case could be 2016, 2019, or Windows Server 2022. The automation also updates or installs the necessary AWS drivers, takes care of upgrading the SSM agent version, as well as making sure that the EC2 config version is uninstalled and the EC2 launch v2 is installed. After the upgrade, the automation creates a new AMI from the temporary instance and then terminates the temporary instance. This AMI is the final result of this automation document, and it is called AWS EC2 Upgraded AMI to 2016 for the instance. Using this AMI, you can then launch the target operating system. Note that there is a pre-upgrade backup that's also taken of the temporary instance. You do have the option to choose if you want to retain this backup or delete the image when running the automation document. Now that we've understood the behind-the-scenes operations of using the automation document, let's kind of switch into the AWS console and actually try out the automation process. I have launched a Windows Server 2012 R2 instance. This instance currently does have an IAM role associated with it. So let me just switch to the IAM console to show you what the role looks like. The name of the role is EC2 role for SSM. It does have a trust relationship for the EC2 service. This is so that the EC2 instance can actually assume this role, and the permissions that this role has is the managed policy for SSM, that's Amazon SSM Managed Instance Core policy. It's essential that you attach this role and make sure that this instance is a managed instance for SSM. So if you switch over to the Systems Manager Fleet Manager console, your instance should be appearing online as a managed instance. This is one of the prerequisites for using the automation document. If you're not aware of how to get an EC2 instance to be a managed instance, I do highly recommend that you check some of my other videos where I've explained what it means to have an instance as an SSM managed instance. I will also try to link that video in the description below, so do go and check that out. So once we've actually configured the instance as a managed instance, let me just switch over to my RDP console and I can show you. So this is the instance that we will be using as an input to the automation document so that we can actually upgrade this operating system to Windows Server 2016. The in-place upgrade is actually performed on the temporary instance. So the result of the automation document is going to be an AMI. So you still have to go through that manual process to launch your 2016 instance. So your original instance, which is Windows Server 2012 R2, is still preserved in the process. So let me switch over to the AWS Systems Manager console, but then go ahead to the automation section where we can actually run this document. Once you're there, click on Execute Automation. We will now search for the automation document that we want to run. So I'm going to select document name prefix equals and type in AWS EC2-clone. So you're going to have sort of 3 automation documents that will pop up. The automation document that we will use today is AWS EC2 clone instance and upgrade Windows. You're going to see there is another automation document that's named quite similar but has a 2019 suffix to it. If you actually open the description of this automation document, you can read that this document is not intended to run by itself, but it actually is invoked from the main document, which will be running. So don't make use of it. Let's go back and use the document that we need to use. So selecting this document, I will scroll down. I'm going to leave it at the default document version and then proceed to click Next. Once you've got past the document details, we now need to provide the input parameters for this document. One of the first input parameters is actually selecting the instance that you want to upgrade. So I'm going to select the instance. You can see this in the list because it's reporting as a managed instance, and that is why it's one of the prerequisites to go through this process. Also, during the course of the automation document, there are a bunch of steps that are going to be run against the instance using AWS Systems Manager run command. So it's essential that the instance does have those necessary permissions. You will notice that some of the parameters are required, as in the case of IAM instance profile, subnet ID, and the target version, but some of the parameters are optional. So we will go through each one of these parameters and try and understand what's the sort of input that it's expecting. The IAM instance profile, this is the IAM instance profile of the role that we actually created. This is also the role that's attached to the target instance, but this is the role that will also be attached to the temporary instance, so it can go through some of the automation steps that require it to be a managed instance. So I'm going to select the name of the role and go ahead and paste that here. For the subnet ID, I do want the temporary instance to also be launched in the same subnet ID as the original instance. So I'm going to just select the subnet ID for the original instance itself. So I'm going to copy that, come back to the documentation and select that here. So my target Windows version is Windows Server 2016. Obviously, for this document, you could select 2016, 2019, or 2022. For today's demonstration, I'm going to select 2016 as the target. The Windows instance does have an AWS provided license. So in this case, I'm not going to be using a BYOL instance. If you are providing a BYOL instance, you can provide the snapshot ID that contains the installation media that you can go through this upgrade process for. As in the case of the alternate key pair name, this is useful in situations if you have lost the key pair that was used for the original instance. I'm going to ignore that here because we are going to use the same password for login to this 2016 instance as we did for the 2012 R2. So you can skip that section here. During the process of automation, there is a pre-upgrade image backup that is taken. You do have the option to retain this backup or delete it. In this case, because I want to show you the pre-upgrade image backup that's created towards the end, I am going to select the option to retain it. However, you do have the option to select false, which is the default option, so that the image is deleted as part of the process. The next option is to reboot the instance before taking backup. The default option is false. I'm not going to change this option, but if you do want to reboot the instance before taking any image backups, you can switch this option to true. Now that we've got all the input parameters covered, I'm going to skip the CloudWatch alarm and the tag section just for the purpose of the demonstration. But if you do need those requirements, please make sure to select it as you go along. And then I'm going to hit the execute button to start this automation. The automation can take roughly about 2 hours or more to execute. It just depends on the steps that it goes through. You could see that it roughly goes through about 60 odd steps. One of the important things that I do want to highlight is when it gets to step 7, you can see that the action is AWS Execute Automation. And this is where the second automation document is actually triggered as part of this main automation document. And we will see that as you switch back to the automation console. You can see that this was the main document that we launched, but as part of this process, a second document is also executed that sort of runs through the process to upgrade the operating system. Don't get confused with the name of the automation document, even though it says 2019. The fact that we have selected the target version is 2016, you are going to see that the final target version is the one that you selected. Just to walk you through some of the steps in the automation document. For example, let's get through the step of get OS version. That's a run command step that the automation document will be running. And you can see that the response code is 2012 R2. So it is identified that your source operating system is 2012 R2. Just like that, the automation document will go through a bunch of steps to perform the upgrade process. And you can track each of the steps by clicking on the step ID and seeing what it exactly does. Since the automation document goes through a number of steps, you may notice that some of the steps may encounter a failure or they may time out. But as long as the automation document actually progresses through, I wouldn't worry too much about this and just let the automation document progress. As long as you get the end result where you do have an image out of which you can launch your target instance version, you're good to go. However, if you do notice that there are steps that fail that ultimately cause the main automation document to also fail, then that would call for a deeper inspection. So you can click on the step ID of the step that actually caused the failure and inspect what the problem is and take it forward from there. So it's important to identify steps that are critical to the process, but there could be some steps that are not critical to the process, but you see that the automation document still progresses. Since this is going to take a couple of hours, please go ahead, grab a cup of coffee or have some lunch and then come back and track the progress of your automation to see if you're good to go. I'm going to give it a couple of hours to complete these steps and then I will see you on the other side. As the upgrade process is running, we switch over to the EC2 console. You can see that a temporary instance has been launched. This is the instance where the upgrade process will happen. And at the end of the upgrade process, the automation document will create an image of this instance. After about 2 hours or so, I see that the automation process has completed. Looking at the screen on the EC2 instances console, you can see that the temporary instance that was launched has now been terminated. Switching over to the automation console, I can see that the main automation document has reported a success. Looking at the screen, you can see that though we triggered only the main automation document as part of the upgrade process, it does execute a couple of other automation documents as well to upgrade the Windows drivers as well as to activate the Windows license on the final target instance. Let's switch over to the EC2 console and take a look at the final AMI that was created for Windows Server 2016. Switching to the AMI's console. As discussed earlier in the diagram, I explained that there would be 3 images that would be created. The first one was the AMI backup from the original instance. This is the backup that was taken on the temporary instance right before the upgrade. And what we're interested in is the final AMI for Windows Server 2016. So this is the AMI that we will now use to launch a 2016 instance and verify that the upgrade process is completed. So selecting that AMI, I'm going to click on launch instance from this AMI. Let me just duplicate the tab and make sure I select the same configuration parameters as my original instance, just so that I can keep it consistent. I'm going to give it a name, Windows Server 2016. Selecting this AMI, I'm going to leave it as T2 Micro. Select a key pair for the instance. I do want to launch it in the same subnet as my original instance. So let me go ahead and find the subnet ID. I do want to select the same security group as my original instance. So scrolling down, selecting the network ID. Let me select the security group, which is Launch Wizard 1. So let me select the security group, which is Launch Wizard 1. Under advanced details, I do want to select the same instance profile. However, this is optional in your case. If you do not want to select the IAM role, that's fine too. And then I'm going to proceed to launch the instance. I'll give it a couple of minutes for the instance to launch and for its checks to pass. I did give it a couple of minutes and the status checks are still initializing. So let's wait for a couple of minutes more. I do see that the status checks for the instance have now passed. Let's proceed to log into this instance now. So let me select the instance, take its public IP, open the remote desktop connection manager. I'm going to paste the public IP here. For the user account, you can use the same credentials as you did for the Windows Server 2012 R2 because the 2016 instance is basically a clone of the Windows Server 2012 R2 just with the upgraded operating system. So I'm going to select the same user credentials that I've saved previously and then proceed to log in to the instance. You can see that I'm now logged into my Windows Server 2016 instance that was upgraded. In order to verify that, I'm going to type in WinWer from the start menu. You can see that it's the Windows Server 2016 instance. Let's take a look at what the upgrade process actually did. I'm going to switch over to my Windows 2012 R2 instance, which was my original instance, and type in appwiz.cpl. You can see that on the 2012 R2 instance, the AWS PV drivers were of the version 8.4.3. We had the EC2 config service and the Amazon SSM agent service was on the version 3.1.2144.0. Let's switch over to the Windows Server 2016 instance and observe the same. You can see that the PV driver versions are the same, which is the latest version in both the operating systems. However, the upgrade process has upgraded the Amazon SSN agent version to the latest version, which is 32985.0. And we also noticed that the upgrade process has uninstalled the EC2 config service and installed the Amazon EC2 launch version 2. So these are some of the steps that the upgrade process has done automatically for you, and you don't need to do that manually. The last thing that I also want to point out is the KMS activation or the Windows Server licensing for the operating system. Let's switch over to the Windows Server 2012 R2 and then run the command slmgr/tlb. We see that the Windows Server 2012 R2 was licensed and the partial product key is MDVJX. And the registered KMS server is 169.254.169.251 on port 1688, which happens to be the AWS KMS server, right? Let's switch over to the Windows Server 2016 instance and then run command prompt as well. And then run slmgr/tlb. So you can also see that the license status is licensed with the partial product key for Windows Server 2016. That's KHKQY. And the registered KMS server is 169.254.169.250, which is also the AWS KMS server, and it's registered on port 1688. In order to verify the partial product key, let's switch over to the Microsoft documentation that says key management, service activation, and product keys, and scroll down to find the product key for Windows Server 2016 standard. And you can see that it ends with KHKQY, which matches the partial product key as seen on the operating system that we've upgraded. So this confirms that the Windows upgrade process is also taken care of the license activation process. Now that you've launched the Windows Server 2016 instance that was upgraded, this is the stage when you can actually test your business applications that were part of the operating system to verify that they're working as expected on the newer operating system. There are two other observations that I do want to point out as part of this demonstration. So let me switch over to the AWS console, AWS Systems Manager. So I did take a look at the steps that was run as part of this automation document. Most of the steps were successful, but when I went to page number 5, I noticed two of the steps, step number 42 and 43, actually failed in my case. However, it did not have any impact on the upgrade process. I did a little bit of digging to figure out what the problem was. The step number 42 actually runs a delete image operation, and it tries to delete the pre-backup AMI. So I took a closer look at that step, and I see that it failed to resolve the image ID, and it returns a pattern validation failure, which kind of indicates to me that it failed to obtain the image ID. So to take a closer look, I did go to AWS Systems Manager document, which is the AWS EC2 clone instance and upgrade Windows. I did scroll down to that particular step to figure out what it exactly does. So when you get to the delete pre-backup AMI from upgrade driver, you can see that it takes the input from a previous step, that is get pre-backup AMI from driver upgrade. However, this step does run another API, which is to get the automation execution, and it obtains the output from that execution. I did notice that the selector was sort of misconfigured. It's written as pre-upgrade backup.image ID. However, if I do go ahead and take a look at the output of this execution, which I will just navigate in a second, I noticed that the output is actually called pre-upgrade backup.backupImage ID. So I see that the term backup has been skipped. So if we switch back here, you can compare the two terms and you will notice that there is a difference here. I do believe that this is a bug and something that needs to be reported to the AWS team for that to be fixed. Switching back, I do want to take a look at the other error that we observed on step number 43. So let's observe what that error was. So what this step actually does is it tries to install the Windows update on the temporary instance. So it tries to install the updates right before creating the image. And taking a closer look, I did notice that the Windows update, which is actually an operating system level activity, actually ran into errors in trying to install those updates. It could be a transient problem in this case. However, it did not have any impact on the OS upgrade process. So there's two ways you can actually tackle this problem. What I would do is I would try to install the Windows updates prior to running the OS upgrade. So when the automation document actually reaches the install updates step, it would probably have no updates to install and it should pass through the steps pretty smoothly. Or there's another way that you can actually tackle this on the final instance that's launched, the Windows Server 2016. You can make sure that Windows patches are updated on that server right after the OS upgrade. So that concludes the process for running the OS upgrade using AWS Systems Manager. Make sure you test this in a development environment first before you directly run it on production server instances. And good luck. Thanks for watching. For more such content, please don't forget to like, share, and subscribe to Unmask It Now. Until next time.